We're going to be walking through how does HTTPS and TLS work, and we're going to be walking through a story in which we, the client, want to open up a bank account with our bank. And so to do that, we're going to need to share some personal sensitive information like our social security number. And so the problem with how you would conventionally do this as like a new web developer is you would post this sensitive data using an HTTP request to the bank. So if I were to go to chase.com right now and go in here and try to go through all these steps, the issue is that if someone was eavesdropping on my network, they would be able to see the entirety of every single packet that I sent between my computer and Chase Bank, which would include my social, my home address, all these other pieces of sensitive information that you could then use to take out another loan in my name. And it would get really messy and bad for everybody. So basically the question here is, when I want to have secure communications with something like a bank, how do I do that using HTTPS? And at the heart of all this stuff is encryption, because encryption is going to help us protect our sensitive data from eavesdroppers. So if someone else is on my network and they're using a network sniffer like Wireshark or those tools, we want to make it very difficult for them to, even if they are able to intercept my packets, be able to read what's in those packets, because that stuff contains stuff like my credit cards and other things like that. So the very first step that happens when I visit my bank is something called the TLS handshake. And so I, the client, make a request to the server, and that TLS handshake is the first thing that goes on here. And so what's going to happen during this TLS handshake is the server is going to return me a certificate. And so it's going to give me back a certificate. And so, if I go to Chase Bank right now, if I go to chase.com, and they hide this in the URLs these days, but you used to be able to see it's https://chase.com. So this is HTTPS, which means we are using that TLS protocol. You can see this little lock icon in the top left, and if you click on connection is secure, it will tell you more information about the certificate. And so if I press on this, you can see that we are viewing the certificate that pertains to chase.com. That is specifically the domain name. You can see also the certificate authority that was here. So in this case, it's Entrust Certification Authority. And so what happens during this process of that first interaction I have with my bank is that they gave me their certificate. And so me, the client, am going to now verify that certificate to make sure it's legit. Because what's to keep me from making a fake bank and then copying Chase's certificate and then giving you Chase's certificate to try to pretend like I'm Chase Bank? And what prevents that from happening is if you view the details of this thing, you can go and see the subject, and you can see that like the common name here is specifically for chase.com. So if my website was called abc.com or chasebank.com, this certificate wouldn't work because that's a domain name mismatch. So my browser, being the client, would say, I got a certificate for this domain that doesn't even match up with the domain I just requested. So this certificate is not legit, and it throws this red block saying your connection is not safe, and you have to like manually click proceed, and that there's a risk here. So that's what's going on there. So basically, first thing is that my client, me, the client, my browser looks at this, says, is this the actual domain I just asked for? In addition to that, if you look at these certificates, you can see that they have expiration dates. And so another thing is I can give you like an expired certificate. And again, my browser checks this for me. I don't have to think about it. But this is what goes on behind the scenes, and it confirms that this certificate, April 26, 2024, hasn't been there yet, and the certificate has been issued on this given date. So the certificate looks good so far. And then the last thing it does is it makes use of these fingerprints, which are basically ways that the certificate authority, so it's going to also forward the certificate that the server just gave me to the certificate authority to say, hey, in this case, it's going to be Entrust Certification Authority. Did you actually issue this certificate, or did someone just BS this certificate and say, we made this up for you? And given those fingerprints, we're going to get a response back from the certificate authority also confirming, yes, this certificate looks good. So this really is chasebank.com. So you are safe to proceed with having a connection with them. Like they really are Chase. So basically this is that authentication step of this process for us to verify that we really are who Chase Bank really is Chase Bank. So that's the whole point of HTTPS and TLS, is that we are getting the server to prove that it's really the server we're talking to, and that only me and the server are going to be able to understand each other. No one else can listen in on our conversations. So that's what's the very first part that goes on here. And so now that we have the certificate, we confirm that the certificate's good, we're happy, we feel like we actually know who we're talking to. The next step here is that we want to do something called generating a session key. And me, the client, gets to pick a random session key to use during this communication. And so I'm going to pick like a random number, and without getting too deep into math, basically there's this thing called symmetric encryption, where you can take some message like the body of your HTTP request that contains my social security number, and by using a symmetric key, I can then encrypt this into ciphertext, and the ciphertext is what actually goes across the internet. So if I delete these arrows, when I want to send my social security number inside the body, it's actually ciphertext, so that even if there was a man in the middle attack going on, you, unless you know how to decrypt that ciphertext, are not going to be able to read my social security number. Now the question is, how do I get my session key, which is this symmetric cipher, from me to my bank? And the issue is that the man in the middle could still read what my session key is and decrypt this traffic, even though they would intercept the ciphertext, and just like the bank is, they're going to decrypt it and again get access to my information. So the question is, how do I make sure that only the server knows what this thing is? And so this is where we're going to make use of a thing called asymmetric encryption. So during asymmetric encryption, what goes on is the server has a public and a private key pair. And so I'll write this out. So basically there's a private key, and the private key is private only to the server. Only the server knows it. I never know what Chase Bank's private key is, but Chase Bank, so I'm going to move this inside of here. Chase Bank issues a public key, and this public key can be known by anybody. And so the thing is, with asymmetric encryption, is that you use your public key to encrypt data, and unlike symmetric encryption, you can't use your public key to decrypt that ciphertext. Instead, what you need is the private key to decrypt the ciphertext, and only Chase Bank has that private key. So basically what goes on here is that the server, they tell me what their public key is, so I know the public key, and a man in the middle can also know the public key. It's totally okay. But what my browser is going to do is, number one, it picks a random session key to go with. And with that random session key, it uses the public key and turns that public key, it uses the public key to turn that session key into ciphertext. And so we have this session key. Let me just add the text. Sorry. So I make a random session key, and then I'm going to pass this session key let me just put in here, this is the session key ciphertext. And what that means is it was encrypted. It just looks like gibberish using that public key. And so this session key from my computer that I picked is going to now go to the server, and the server is going to use its private key to now decrypt that session key, so that at the end of the day, what happens here is that the server now knows the session key that I picked. Okay, so hopefully this is making sense. So now the server and me have a session key, and an attacker, so if I was to draw another box like this, so someone trying to figure out what my credit card or my social security number is, even if they were able to intercept this traffic, they're only seeing the ciphertext, and because they're only seeing the ciphertext, they are not able to know what my session key is. And so once all this has happened, the cool thing here is that only me and the bank, Chase Bank, are able to encrypt and decrypt stuff now using that session key that only us two know. And so using symmetric encryption, I'm now able to send stuff like, so I'm going to delete this. Let's say I had my social security number. And so I want to pass my social security number to Chase Bank. So what's going to happen next is we're going to have this arrow come through, sorry. I'm going to have an arrow come from there to there. So my social security number ciphertext is going to be passed from me to the bank, and then within the bank, they'll be able to decrypt it. Why? Because they have the session key that I made up to encrypt our communications symmetrically. But the attacker, again, even if they are able to listen in on this conversation and intercept the ciphertext between me and the bank, it's not going to do them any good because they don't have the session key that me and only the bank, Chase, knows. And so that is how we're going to have this secure communication for us in this story. So that is how HTTPS and TLS work. It definitely is complicated, but it is how we do a lot of stuff on the internet these days, and how we make sure that people like the NSA and others can't read all of our traffic, so we can actually have secure communications with other people online. So I hope this is helpful stuff. Thanks all for watching. Let me know if you have any questions, and be well.